microcontroller developers. So meet the Education Booster Pack. So Circuit Code has done a great job in packing a lot of functionality into this very affordable kit. As you can see from the picture as well as from the slide, on board we have the 3-axis accelerometer for measuring motion. We have a 16 by 2 character LCD display with backlights. We have a piezo buzzer, a microphone, a tricolor RGB LED, another white LED for your liking, and an analog potentiometer. So in addition, this entire hardware system is immediately supported by the existing code examples. As a matter of fact, for each of the listed components that I just mentioned above, there is a list of APIs and core APIs provided immediately for usage. So this booster pack is already available for order today on DigiKey for just $19.95. So you can definitely learn more about this booster pack, including documentation, code examples, pinout. Everything is available on the Circuit Code Wiki, which is available on this link. To be honest, we can't wait to see all the cool projects that you guys can come up with this booster pack and with using the onboard components as well as external components. But by the end of the day, we'll share with you an example of a project that we developed with this booster pack in our demonstration. So now we have taken a good look at the Launchpad and the booster pack hardware that makes up the Launchpad ecosystem. Let's take a look at our final piece, the software. So software is the final piece, but it is also a very important piece of our Launchpad portfolio. With the Launchpad, we wanted to provide a scalable software ecosystem that would provide various options for different level of expertise and audiences. So some of the software tools are intended for beginners, while some other are more fully featured and they're intended for professional engineers. So one part of the Launchpad software ecosystem is a great community-driven project that TI sees a lot of value in. The MSP 430 online community has banded together to create a simple, open-source, intuitive development environment that may be a lot familiar to many hobbyists. It is also supported by a vast collection of easy-to-use APIs for talking to your Launchpad hardware. So through the use of this simple function call, users can read analog signals, they can generate PWM signals, they can send and receive serial communication, and they can pretty much do many other things, all thanks to the effort of the online community. So for that, on behalf of TI, we want to say thank you to the contributors and the users involved in Energia. Also, as a member of the community, individuals from TI also have contributed to the Energia project. We're helping the movement to contributions by working together with the Energia team to port code to new devices, as well as creating new APIs and libraries for the new booster pack. So today, Energia supports the MSP 430 Launchpad, and even more exciting than that, we have a really good news to share with you guys. So just last night, the Energia team released a new update for the Energia software that now includes the support for the Stellaris Launchpad and another MSP 430 board that's lovely called Launchpad. So definitely find for more information about Energia at www.energia.nu. You can also find a lot of active and engaging conversation or help and support on Energia at www.430.com, which is a great online community that focuses on Launchpad. So as you can see from the slide, the APIs have been ported to Energia, provide a really high level of software abstraction, which enables developers to fly high above the bits and the bytes of register level programming. So this is really ideal for software developers as well as for even hardware developers who just want to rapidly prototype something and enable just quick proof of concepts. So during our demo later on today, we'll be using Energia to program the new education booster pack, and we hope to demonstrate how this community-driven and generated tool can help you make the Launchpad much easier to work with. So on the other side of software development, we have another component to our software story, which is the Code Composer Studio. So TI's Code Composer Studio, also known as CCS, is a fully featured professional development environment that actually supports all of our embedded processors available from TI. So it's an Eclipse-based development environment, and it provides a full debug capability and more for all three of our Launchpads. So with CCS, users can step through the code, set breakpoints, watch variables, look at the register, and do many other things internally to the device. However, this great power comes with a great responsibility because it's not as simple as Energia. CCS is a great tool when developers need the added optimization, the improved features, as well as the full debug capability. Also, CCS offers a unique resource packages and driver libraries for MSP430, Stellaris, as well as C2000. So these resource packages are pre-installed inside CCS, and they serve as a one-stop shop for MCU resources, code examples, documentations, and more. So as you dive deeper in our Launchpad ecosystem, you will find that there are a lot of other software options beyond Energia and CCS. Launchpad is supported by TI software as well as by third-party tools, and we are really confident that you can find the right tools that will suit your specific needs as well as expertise. All right, so now we have covered the components that make up the Launchpad ecosystem. We have touched the hardware, the Launchpad itself. We have also mentioned the booster pack, which is the adapter board to go on top of the Launchpad, and finally the really important piece of software that ties everything together. At this point, we would like to show you a quick demonstration of what the ecosystem can enable for you. So we'll be using the MSP430 Launchpad, and we will pair this Launchpad with the new education booster pack. So using Energia, we will run through a few code examples, as well as show one example project, one example application that we developed to show how we can tie these various different hardware components together to create a meaningful and, more importantly, a fun application.
Alrighty, so let's go ahead and get Energia set up on our computer. The place that you'll go to is energia.nu. So this is a great little website that the community has generated to really house all the resources associated to Energia, as well as information on download. You can see that there's a couple of Energia deliverables available. In this example, we will be playing with the Windows version. And what's great about Energia is that it's actually delivered in a zip file. So there's actually no install process. You simply download the zip, unzip it to your desired location, and run the executable. And we've actually done that already, as you can see here. So all we have to do to run Energia is double-click this executable. And that'll open up a blank development window. Sort of the first thing we notice when we see Energia for the first time is that the community has done a great job creating a very familiar development environment that's very intuitive. It's also very simplified. So you just get a couple of buttons, you have your code editing area, you have a little console for any updates. There's also a serial monitor for reading in serial data that's coming into the PC from your Launchpad. But probably most interesting are the examples that are provided inside of Energia. As you can see, there's quite a few ranging from different types of categories. And what's great about these code examples is that they demonstrate a lot of the available APIs that are provided inside of Energia. For our first example, we are going to use analog in out serial. And what this does is that it teaches us how to read an analog channel and send it to our serial monitor. It also allows us to take in that analog reading and use that to affect the brightness of an LED. So it's a really cool code example that allows us to tie in a couple of inputs and outputs to generate a very simple application. So let's walk you through the code very quickly. The first thing that we do is we use this available API called analog read, and this basically reads in an analog channel and saves that value into this variable. And depending on our analog reading, we run it through this mapping function, and the output of this mapping function is what we then pass into another function called analog write. And what analog write does is that it takes in, or it actually affects the PWM, the duty cycle of a PWM that is tied to a particular port pin. In this case, we are going to tie that port pin to an LED. So as we change the position of our dial on our potentiometer, it affects this analog reading, and as that analog reading changes based on the potentiometer's position, we are able to then send those new values into analog write, which causes the LED to again change its brightness. In addition to changing the brightness of the LED, we are also sending back the sensor data back to our computer using the serial monitor. So it's a very simple application, and as you can see, it does a decent job demonstrating some of the available APIs that are inside of Energia. And it also, I think, does a great job showing off how we can use clever software to combine some of these components that are available on our booster pack hardware. In this case, we're combining the potentiometer with the RGB LED. So before we can use this code example, we actually have to modify it a little bit. As you can see here, we define the analog input pin. It's defaulted to A0. However, when we look at our booster pack, we need to make sure that we're talking to the right pin. And we can do that by going to the Educational Booster Pack Wiki, which is what the circuit code guys have put together. We can click on this link here for signal usage, and this summarizes the pin assignments for those different components on your booster pack. Here is the potentiometer, and we can see that it's tied to channel A3. So we can go back to Energia and make that modification to the code example. So these code examples are pretty generic. They're meant to enable you to do any application, but because this booster pack was designed with Energia in mind, we're able to leverage a lot of these code examples through very simple modifications. So one thing we need to do is tie the analog input pin to the potentiometer, which is A3. And now we need to make sure that the analog output pin is tied to the right LED. And we can again go back to the wiki. And let's say we want to change the blue channel of our RGB LED, and we can see that that is tied to P2.4. So going back to Energia, we can now make that change to make sure that we are talking to the right LED. Now at that point, our code example is ready to go. We can press this button here to compile the code and download it into our Launchpad. And at this point, our Launchpad microcontroller is being reprogrammed. Once it's done being programmed, the application runs immediately. And as you can see here, we have our new code, and the RGB LED is changing its brightness based on the position of the potentiometer. So as I turn the position of the potentiometer dial, we can see that the LED becomes very dim or very bright, depending on the position. So this code example is very simple, but I think it does, again, a very good job showing us how some of these hardware modules on this booster pack can work together to create a complete solution.
In this example, as you can see, as we change the position of the potentiometer, the LED will turn on accordingly. So essentially, you just created yourself a light dimmer switch. This example combines the analog input received from the potentiometer and provide the analog output on the RGB LED, in this case the blue channel.
Sweet. And as we take a look at this example window inside of Energia, we can see that there's code examples for many things. We have code examples available for this LCD display, code examples available for the buzzer, code examples available for the analog accelerometer. And by tying all of these code examples together, we can again create some interesting application. And to demonstrate that, we actually created a sample project, which we call Thief Detector. And what this example does is that it takes in the accelerometer.
So as you can see, when first loaded, the application reads the values from the 3-axis accelerometer and display the resultant vector on the LCD screen. When this value increases beyond a certain threshold, it would sound the buzzer and turn on the LED alerting that a thief was detected. So let's see in action. One more time. So as you can see, this is a really simple application that shows how you would combine simple components from the input to output, from the accelerometer analog reading to analog output reading on a buzzer or the LED or on the LCD screen. And it only involves using core APIs provided by Energia. The thief detector is just one example application that we came up with to demonstrate a simple way of using Energia to create a cool application. With several analog and digital components on board, there are potentially so many combinations to create cool applications. For starter, some of the ideas might include, for example, you can use the potentiometer and the RGB LED to create a dimmer, or you can tie the accelerometer with the buzzer to create a musical instrument that changes the pitches depending on your tilting angle. Or if you want to get even more creative, you can use this alligator clip connection to connect this pin to a doorknob and turn your thief detector into a intruder detector. Or yet another example, maybe you can use a computer to connect to the launchpad and provide information that which can be updated on the LEDs. Or you can use a computer to send update messages to the LCD screen or the RGB LED. For example, when your friend tweets you, it will display the message on the LCD screen. Or vice versa, if a thief is detected on the board, it will tweet you back. So cool. Very simple application. We hope that it gets you excited about what you can do with the technology. We would also like to challenge you to think of other ideas and come up with even more applications using the Launchpad ecosystem. We just can't wait to see what you guys can come up with. And of course, special thanks to Circuit Code for creating this awesome booster pack. And a very special thanks to the online community who developed Energia. These guys have created an amazing tool that hobbyists, students, and even engineers can benefit from. We really appreciate the community effort in creating a tool that really opens up new opportunities that we are really excited about. So that concludes the demo. And now let's head back to the...
Cool. So that was a demonstration which ties together the Launchpad ecosystem. To sort of recap, again, we have our Launchpad baseboards, which are based on TI MCUs, including the MSP430, Stellaris, and C2000 microcontrollers. Again, these Launchpad kits are also supported by a growing ecosystem of plug-in modules, which we call booster packs. And lastly, the Launchpad hardware is supported by scalable software solutions and tools to help get you up and running in no time. So hopefully, with the help of this demonstration, you were able to see firsthand just how Launchpad, in combination with the booster pack, in this case the education booster pack, was able to provide a flexible development environment for rapid prototyping and generating quick proof of concepts. And thanks to Energia, and I guess more importantly, thanks to the community who has helped generate Energia, we're able to leverage existing APIs and code examples to do quick evaluation and prototyping. So with that, we conclude the Launchpad webinar in terms of content here. And we hope that you enjoyed it, and we're so glad that you chose to spend some time with us today. And we hope that you're as excited as we are about the Launchpad. And we truly can't wait to see the crazy ideas and projects and solutions you guys create using this ecosystem. And last but not least, again, we want to take one more opportunity to say thank you to the growing community of Launchpad users. We're extremely humbled by the online community and the contributions that they've made to make this ecosystem as strong as it is. So definitely keep up the good work. It's been awesome.
Okay, well, we'll jump right into the questions that you have submitted in just a second. We've actually got hundreds of them, so we're not going to make it to all of them. For those we don't answer, we're going to be sending you emails in response, but we'll try to get to as many as possible. And we may even run over a little bit on our time, but we're going to be allowed to do that.